Hi guys, we are going to do lesson 1.0b today on fractions, decimals, and percents. And I would encourage you to watch the first couple problems in this video, and then if you're feeling really comfortable on this stuff, it is mostly review, then go ahead and pause the video, try a couple more on your own, and then go ahead and continue watching to check your answers. So we are being asked to write the equivalent values for the following parts of a candy bar. So I'm just going to pretend it's a Twix because that's my favorite. The bar on the left is divided into two equal parts. So if I take one part of 2, as a fraction, I would say this is 1 of 2. As a decimal, I know that this is just 0.5 or 0.5, and as a percent, we know that this is just 50%. If I'm going to take 2 parts of 2, this as a fraction is just 2 over 2, which we know any number divided by itself is just 1. So as a decimal, this is just 1 or 1.0. And as a percent, this is actually 100% of that candy bar. So the second one, if I take 1 part, this is 1 part now of 3. And as a fraction, I know that this is 0.3 repeating forever. If I'm going to convert that decimal to a percent, I need to move this decimal point 2 places to make it a percent. So this is 33.3 repeating percent. If I take 2 parts, this is now 2 parts of 3. So this is 2/3 as a fraction. As a decimal, I know that this is 0.6 repeating. And now from a decimal, I need to move my decimal point 2 places to be a percent. So this is 66.6 repeating percent. The third one, we now have 4 parts. So 1, 2, 3, 4. So if I have 1 part, this is just 1 of 4. And as a fraction, it's 1 of 4. As a decimal, it's 0.25. And as a percent, it's 25%. If I now have 2 of 4 parts, well, this is now half of that candy bar. And I know that half is just 0.5 or 50%. If I have 3 parts of this candy bar, this is 3 out of 4 as a fraction, or 0.75 as a decimal, or 75%. The bar on the left is now divided into 5 parts. So if I have 1 part, this is now 1 of 5 as a fraction. As a decimal, I know that this is 0.2 as a decimal and 20%. If I were to take 3 parts, this would be 3 of 5. And now I know that 3 of 5 is 0.6 or 60%, which makes sense because if I have 1 part and that's 20%, 3 parts is 3 times that, or now 20% times 3 is now 60%. Okay, now if we divide it into 6 parts, it's 1 of 6. And as a fraction, this is getting a little bit trickier. So you're welcome to use a calculator here. You could also divide. If I were to come over to the left here, this would be 1 divided by 6. So make sure you don't get that confused. And we know that 1 does not go into 6, so I need to make a decimal point right there. 6 goes into 10 once. If I were to do 6 times 1, I would get 6. 10 minus 6 is 4. And then I would need to make another 0, bring it down. So now I have 6 goes into 40. 6 times, I know 6 times 6 is 36. 40 minus 36 is 6. And this is actually going to just continue on repeating. So 6 goes into, oh, here, I wrote 6 instead of 4. So this is another 40. I would see 6 goes into 40 again. I know that this is just going to keep repeating. So my decimal is actually 0.16 repeating. And from a decimal to a percent, I'm just going to move this 2 places, so 16.6 repeating percent. If I have 2 parts of 6, that would be 2 of 6, but I want to write this simplified. So 2 parts of 6 is also the same as 1/3. And we already wrote that this was 0.3 repeating as a decimal, or 33.3 repeating percent. If I now have 3 parts, this is 3 parts of 6. So I'm writing it over here first because I know that I want the simplified fraction right here, which is just half, 0.5 as a decimal, or again, 50%. And this last one is divided into 8 equal parts. So if I have 2 of 8, this would be 2 of 8, which is really 1/4, or 0.25 as a decimal, and 25%. If I have 7 parts, this is 7 of 8. And again, this is a tougher one that you'd need to use long division, or you may use a calculator on these ones. 0.875 is what this would be as a decimal. And if I move a decimal to a percent, I move it 2 places. So it's 87.5%, which makes sense because 7 of 8 parts is almost the whole candy bar, and 87.5% is almost up to 100%. So we're now going to go to the next page here. And it says, to the left is a 10 by 10 grid. Why do you think it's called a 10 by 10 grid? Well, if I look at here, there are 10 boxes by 10 boxes. So I'm going to say the length and width are both 10 units. How could you use a 10 by 10 grid to show the fraction 6 of 10? So if I were to show this fraction in this grid, you would just shade in 1, 2, 3, 4, 5, 6 boxes. Shade in 6 boxes. Because this is 6 out of 100. We know 10 by 10 is 100, so there are 100 total boxes. And we just shaded in for 3. What fraction is shown in this 10 by 10 grid here? So it's talking about this one. So now I have 1, 2, 3, and I know that this height is actually 10. So I have 30 here plus 1, 2, 3, 4, 5, 6. So this is 36 out of 100. But I know that there are numbers that go into both 36 and 100. So I can actually reduce this fraction. So I could start by saying, well, I know that 2 goes into 36 and 100, but I also know that 4 goes into 36, and I know that 4 goes into 100. If 4 goes into 100 25 times, 4 goes into 36 9 times. So this is actually equal to 9/25. What is the decimal equivalent for this fraction? Well, in order to find the decimal, it's actually going to be easier to use this first one because it's already 36 out of 100. So I just need to write 0.36. What fraction is shown in this 10 by 10 grid? So in this 10 by 10 grid, I now have 2 rows, or I should say, 2 columns full. So this is 20 boxes that are shaded out of 100. And we can write this as a simplified fraction, which is actually 1/5. And the decimal equivalent for this fraction is 0.20, or you could just write 0.2. Either of those would work. Okay, so now we're going to do some shading. Shade in the given decimal in each grid below. Well, 0.27, I like to think of this as a fraction if I'm going to shade it in. So 0.27 is 27 out of 100. So I would shade 27 boxes because I know this is a 10 by 10 grid. So this is 10 and 20 here. So I'm going to shade all of those. And then 1, 2, 3, 4, 5, 6, 7. So that's 27 out of 100. Now this is 0.4. I could also write this as 0.40. That's actually the same thing. This is 4 out of 10, or 40 out of 100. These are all the same amount. Okay, so I want to look at this one because I have 100 boxes and I'm trying to shade in out of 100. So now I have to shade in 40 boxes. So this is 4 here by 10. So all of this would be shaded. So I have 4 wide and 10 height. Now, 0.125. This is a little bit more challenging because to get rid of the decimal, I now have to move it 3 places. So this is 125 out of 1,000 now. And I want to see what this is. This would be out of 100. So how many boxes would I shade out of 100? Well, if I were to just write this out of 100, that would be 12.5 boxes out of 100, which we really don't want to write our fraction like this because there's a decimal in a fraction. So normally we would never write that, but in this case, it's going to help us actually shade in the boxes. So here are 10 here, and then 2 more, and then just half of a box here. Let's see if I can do this on the computer. Yep, just half of a box there. So if I were to write this, I would actually just reduce it, and this fraction reduced would end up being 1/8. Okay, and we already did this one. Up here, we were writing the fraction represented in the model. So I just wrote it up top. Okay, so moving on to our last page. Shade the fractional part of each grid. Okay, so again, we're going to shade in the fraction of each grid. And the first one is 1/4. Well, I need 1/4 out of 100 squares. And I think of this as if I have 1/4 of $1, 1/4 of $1 is a quarter or 25 cents. So I need 25 boxes shaded. This is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So I'm just going to shade in this whole 5 by 5 square because this is 25 boxes. I'm going to rewrite this as 25 out of 100 too. As a decimal, this would just be 0.25, and as a percent, we would just move it 2 places, 0.25%. 1/10, if I were to write this out of 100, this would be 10 out of 100, or 10%, and 0.10. If I'm going to shade this in, this is just 10 boxes. Now, 1/5. If I'm going to think of this out of 100, 1/5 of 100 is 20. So I need to shade in 20 boxes now. And if I'm going to write 20 out of 100 as a decimal, that's just 0.2. And as a percent, that's just 20%. Okay. Now, 1 out of 100 is literally just 1 box. So this is going to differ from 0.1. This is a really big mistake I see is we sometimes get 0.1 and 0.01 confused. So if I have 1 out of 100, I have to write 0.01, not 0.1. And as a percent, this is just 1%. So 1 out of 16 is a little bit trickier because I can't really think, what's 1/16 out of 100? I don't already have that in my head. So I would actually need to divide 1 by 16. And now obviously 16 doesn't go into 10, doesn't go into 1, doesn't go into 10. It does go into 100. And I keep that decimal point. It goes into 100 6 times. If I were to do 6 times 16 on my calculator, I would get 96. And 100 minus 96 is 4. I'm going to bring down a 0. 16 goes into 42 times. And then I have 40 minus 32 is 8. I'm going to bring down one more 0. And 16 goes into 85 times. So 1/16 as a decimal would just be 0.0625. And as a percent, remember, we're just going to move it 2 places. And I'm doing this first because it's going to be a little bit easier to see how many boxes we shade. So if I'm going to move the decimal point 2 places, 6.25%, which means that if I just had 1% over here and I just shaded 1 box, I'm going to shade 6 boxes, 1, 2, 3, 4, 5, 6, plus just 1, oops, I didn't mean to erase that, quarter of a box. 0.25 is just 1/4 of a box. And then 1/3, we know that to be, as a decimal, 0.3 repeating, or as a percent, 33.3 repeating percent. So now I have to shade 33.3 boxes. So I'm first going to shade the 30. This is 3 by 10 here, so that's my 30. And then 3, and then just 1/3 of a box. Okay. Now, use long division to show how you can convert each fraction to a decimal and then to a percent. So I'm going to go a little bit darker on here. Each fraction to a decimal and then a percent. So if I'm going to divide 3 by 10, it's going to be a smaller number than 1 because 10 out of 10 is 1. So if I'm going to put the 3 under here and the 10 here, and I know right away I'm going to need a decimal because I know 10 does not go into 3. But 10 does go into 30 exactly 3 times. So this is just 0.3, and as a percent, this is just 30%. 2 divided by 5, again, it's going to be smaller than 1. So 2 divided by 5, my decimal will go right here and right there, and I have to add a 0 right away. So 5 divided by 20 is 4. So now I have 0.4, and as a percent, this is just 40%, which makes sense because we know that 2.5 is half of 5. This is a little bit less than that. 3 divided by 8. So really it's going to be a little bit less than half, right? We should already be thinking about that to check our answers. So 3 divided by 8. Put my decimal right there and add a 0. So I know 8 goes into 30 3 times. That will be 24. And then I get a 6 here, so I have to bring that down. 8 goes into 60 7 times. I know 8 times 7 is 56. And, okay, good. I know 8 goes into 40 5 times. So as a decimal, 3 divided by 8 will be 0.375. And as a percent, 37.5%, which is a little bit less than 50%. And lastly, 2 divided by 9. So 2 divided by 9. 9 goes into 20 2 times. I can't forget my decimal. And that will be 18. And I can already see that this is going to repeat. So this will be a repeating decimal, 0.2 repeating, or 0.2 repeating. And as a percent, this is 22.2 repeating percent. And that is it for our lesson today.